So you guys have already seen a PowerPoint where you kind of get a brief summary of how ions form. First of all, on page 381 of your book, there is a chart of ion charges, and I did put a very similar chart into chapter 5. It was, not chapter 5, chapter 15. Sorry, wrong class. Chapter 15, it was in chapter 14. I moved that periodic table with ion charges into the current chapter. Okay, so we're going to look at how ions form from atoms. First of all, atoms, as you remember, have no charge because the number of electrons equals the number of protons. Atoms can form charged species known as ions. They can form charged species called ions. You can't tell that that says called. I can't even tell that that says called. There are two kinds of ions. There are positive ions, which are called cations. These are not cations, but cations. And there are negative ions called anions. The best way I have found to remember which is the T in cations looks like a plus sign, positive, you get it? Positive has a T, cation has a T. Okay. To form a cation, an atom has to lose one or more electrons. It seems kind of funny to get something positive, you've got to get rid of something, but you do. So let's take a look at sodium. Sodium, whose symbol is Na, likes to form a +1 cation. When we only have a single charge, we just put a plus or a minus, we don't put a number by it. Okay, sodium, if you look at the periodic table, has 11 protons and 11 electrons, and if you add those up, you get a net charge of 0. If you form a sodium +1 cation, you have 11 protons, 10 electrons. If you have 11 positive things to 10 negative things, you get a charge of +1. So while we've lost something, we've lost one electron, we end up with a positive charge. Aluminum always goes to aluminum with a +3 charge. Notice it's got a charge other than 1, so I have to put what the charge is. Aluminum starts with 13 protons and 13 electrons, and as an atom, it has 0 charge. Aluminum +3 still has 13 protons because it is still aluminum. You can't go to 16 protons because then it's something else. It has to have 13 electrons. The only way I can get a +3 charge is to lose 3 electrons. 13 positive things plus 10 negative things gives you an overall charge of +3. That's how cations are formed. Like I said, it's really important here. Atoms cannot change their number of protons. People always forget that. Don't forget that. To form an anion, an atom has to gain one or more electrons. So fluorine likes to go to fluorine with a minus sign. Fluorine has 9 protons, 9 electrons for a charge of 0. The fluoride anion has 9 protons because it's still fluorine. It has 10 electrons. If you add 9 positive things to 10 negative things, you get a charge of -1, which is seen right here. Sulfur becomes the sulfide ion with -2 as its charge. The sulfur atom has 16 protons and 16 electrons for a sum of 0. The sulfur anion has 16 protons because it's still sulfur. It has 18 electrons because it needs a charge of -2. 16 positive things and 18 negative things gives you a charge of -2. And the last thing your book talks about, very, very briefly, are molecules forming ions. These molecules that form ions form what are called polyatomic ions, many atom ions. All but 2 of them are negative, meaning only 2 are positive. And the very first example I thought of was one of the 1 positive ones. So if you have ammonia, which is NH3, if you add a positive hydrogen ion, known as a proton, to it, it's going to bond to the nitrogen in the center like this. And we've added something with a positive charge. So all of these 5 atoms, 1, 2, 3, 4, 5, now share a positive charge. Where before these 1, 2, 3, 4 had no charge, and this one had a positive charge. So you just add something positive to something neutral to get a molecule turning into an ion, a polyatomic ion. This is water. Water is H2O, but lots of times it's easier to think of it as HO and then another H. If water breaks apart right here, you have an OH or hydroxide anion and a proton or a hydrogen ion. Okay, so this OH has a negative charge and this H plus has a positive charge. If those two came together, you added two ions, you'd get a neutral species. On page 382 of your textbook, there is a table of commonly used polyatomic ions. But we're really not going to talk about how they're made, but you ought to be familiar with this page and this table. That's it.